All right, welcome back, you derivative-loving fools. Let's go ahead and find the derivative again of some exponential functions. And in this case, we're going to look at our product rule and our quotient rule and chain rules and some different things as we get along with this. So today, we're going to look at the derivative, and we're going to simplify f of x equals 5 times the quantity of e to the negative x minus e to the x. So to find the derivative of this, recall this 5, there's no variable with it. So to find the derivative, f prime of x, that's going to equal, well, we can take our 5 and multiply it by the derivative of the interior part there, or that quantity. So the derivative of e to the negative x, recall from our previous lesson that the derivative of e to any exponent is found by taking the derivative of the exponent, multiplying it to the front, and then leaving the exponent of e alone. So the derivative of negative x is going to be negative 1 e, and then that x, or that negative x, that exponent is going to stay the same. Minus derivative of e to the x, which we again recall from the very previous video, derivative of e to the x is, of course, e to the x. Now, I personally do not like that negative exponent, so I would like for you to go ahead and clean that up. And there's lots of things that we can do to clean that up. One, negative exponents we can take to the denominator and make it a positive. And this is the least that I want to see you do. We could also go ahead and find a common denominator for these two terms. And if we were to do that, the denominator would be e to the x. So I have a negative 1, since that already has a common denominator. And if I take e to the x, that's over 1. Its common denominator would be e to the x, so 1 times e to the x gives us that e to the x. So we multiply e to the x times e to the x. And recall, when we multiply common basis, we're going to add the exponent. So x plus x gives us 2x. So we'd have negative 1 minus e to the 2x. And that's going to be over e to the x times our 5. And that'll be our first derivative. And that would be something that I may do on a multiple choice type of question quiz, but definitely we want to make sure that we do not have that negative exponent as you do your assignments. Here we have a nice little quotient rule. So we're going to call our quotient rule. We're going to sing that little ditty. We have low. Our low is just e to the x. We're going to leave that to the same. And then derivative of the numerator, d high. So derivative of 5e to the 3x. Again, we take the derivative of the exponent. Derivative of 3x is 3 times 5 gives us our 15. And then e to the 3x. Again, the exponent does not change. Derivative of 1 is 0. So we have e to the x times 15 e to the 3x. Minus our high, which is 5e to the 3x plus 1. Derivative of the denominator, which is going to be e to the x. All over e to the x squared. To clean this up, I notice here that I have e to the x in both my numerator terms. So I'm going to go ahead and factor out that e to the x. And we left with the 15 e to the 3x. I'm going to multiply this negative through, so I get a minus 5e to the 3x minus 1. All over e. And again, we have e to the x squared. We're going to multiply those exponents by our exponents rules and get e to the 2x. I can go now ahead and cancel an e to the x out of the numerator and denominator. So I'm going to be left with that 1. I'm going to go ahead and clean up my numerator as well. 15e to the 3x minus 5e to the 3x is 10e to the 3x minus 1 over, when I cancel out an e to the x as numerator and denominator, I'm going to be left with e to the x in our denominator. And that gives us our simplified answer. Got quite a few other ones to show you today. Here we have 2e to the negative 2 over x. So what I like to do with this one, notice our exponent here is negative 2 over x if you wish to write it like that. We're going to find the derivative of that. So what I like to do is come over here and say g of x is going to equal that exponent. And I'm going to write it as negative 2x to the negative first. And I arbitrarily let it be g of x. It's any function we want. It could be h of x, I of x, doesn't matter, as long as we don't make it be f of x, because we've already used our f of x. So our derivative is going to be a positive 2x to the negative second, or 2 over x squared. So I'm going to take that derivative and multiply it to my numerator, or sorry, my coefficient. And 2 times 2 over x squared gives me 4 over x squared. And then and then again, that exponent is not going to change, it's negative 2 over x. Again, though, remember, we don't want a negative exponent when we leave our answer. So we're going to take that to the denominator, which we've already started in the denominator, is going to be the x squared. So we're going to have it as x squared e to the 2 over x. And that's going to be my derivative. Here we have e to the radical x. Again, I'm going to come off to the side and let g of x equal that square root of x, which again is x to the 1/2. My derivative of that exponent is going to be 1/2 x to the negative 1/2. So I'm going to multiply that to my numerator, keep saying numerator, my coefficient of e, which is 1. So f prime of x is going to be that derivative, 1/2 x to the negative 1/2, and then e to that same radical, x. Again, remember that denominator, or that exponent never changes. I can't get my words right today, can I? Again, we have negative exponents. We're going to take that out of the numerator and take it to the denominator, which we've already started with a 2. I have a 1 in my numerator and e to the radical x, so I just have e to the square root of x over 2x to the 1/2. For our derivative here, we have f of x equals e to the negative 3 over x plus 3e to the 2x. So since we're adding, and we have two separate functions, we can find the derivative of the first function and then add that to the derivative of the second function. So we've talked about this e to the negative 3x. Well, we had e to the negative 2x up here. Recall the derivative of negative 2 over x gave us the positive 2 over x squared. So if I just replace that negative 2 with a negative 3, it's going to work very similar. I'll just have a 3 over x squared. So to make our life a little easier, since we see that pattern, I get 3 over x squared e to the negative 3 over x. To that, we're going to add the derivative of 3e to the 2x. Derivative of 2x is 2. We'll multiply it to the 3, and I get 6 e to the 2x. Negative exponent, I'm going to take it to the denominator. So I have 3 over x squared e to the 3 over x. And to that, we're going to add 6e to the 2x. And that gives us our final answer. And I have just one more example. And the reason I want to do this one is because it's a little product rule. I have 3x squared times e to the negative x. Notice I have x's in two different parts, and I'm multiplying those two different parts together. So my derivative, I have to use a product rule. I can treat this 3x squared as one term, or we can treat this 3 as a constant and multiply it to everything. So we could write it as 3 times the derivative of x squared e to the negative x, or we can leave it as 3x squared as one term times e to the negative 3x. Most people like to leave it as 3x squared, kind of leave it together, so I'll go ahead and do that. So we have 3x squared, derivative of e to the negative x is negative e to the negative x. To that, we're going to add the second, which is e to the negative x, and then derivative of 3x squared is going to be 6x. Now we can go ahead and clean this up a little bit. I have an e to the negative x in common, I have a 3 in common, and an x in common. So I'm going to take out a 3x e to the negative x. And that's going to leave us with this negative and an x, so a negative x. Over here, if I take out a 3x e to the negative x, I'm left with a 2. So some people don't like this negative in front of the x. We can definitely take that out as well. I definitely don't like this e to the negative x, so I'm going to take that and make it a positive by taking it to the denominator. So I'm going to have 3x times negative x plus 2 over e to the x. But we could also take out that negative, and we get negative 3x times x minus 2 over e to the x. And that gives you some examples of using the product, the quotient, and our power rule for exponential functions. Good luck, enjoy. If you have questions, let me know.